Good evening, and welcome to my talk about an advanced wall system in a heritage project. Retrofitting a heritage cabochon building to a sustainable standard. Here we go. In 2005, Monica and I were able to purchase the house next door to our home in Cabbagetown. Wow. Now we can actually combine and apply many of the sustainable concepts and systems we have been researching for years. That would be the one we purchased. Right there. That's where we were living. Here's the basic house. The one on the left. Brick veneer front. No insulation anywhere. Nice air between the brick and the walls. Air moving up everywhere. Cement parging on the side and back walls. Lath and plaster on the interior. Just exactly as it was in 1890. A perfect example of building in 1890. As we started the project, we realized that the before reno data was very important to us. We did a blower test and collected data on previous year's utilities bills. This is the blower test at the beginning. We did one at the end as well, but we realized that we needed to base it on something. How well did we do on this project? While we were gutting the house, we consulted with sustainable engineers from Sustainable Edge and researched and selected our team of trades and suppliers for the project. When I mean researched, interviewed 4 of each trade that we were dealing with here. Do you want to do a sustainable project? Do you have any experience in sustainable projects? Do you know what a sustainable project is? So I have to emphasize that the success of this project is the result of many forward-thinking, enthusiastic, and progressive team members. It's not just me, it's not just Monica or the carpenter. It was a whole group of people that were all participating. Let's take a look at the final design of the wall assembly we're going to talk about today. Here it is. That's what we're going to talk about today, and we're going to get into some details now. The question that we had is, how do we get a high R value from an existing wall without disturbing the exterior during the construction? Now, I know that many of us in here have been dealing with a heritage or an existing structure and have thought, wow, what am I going to do? Because you want to keep the heritage, you want to keep the brick, you want to keep all the good stuff, but what are we going to do? Well, in our case, the easy answer, pretty much the only answer that we had in our hands that time was to build inward. We sacrificed 2 inches on the inside of the exterior walls. We'll look at it in a minute. There's the 2 inches right there. Now, let's take a look at this section. We're going to start on the right side. These are all the existing structures here. We start from the outside, from the existing metal cladding, through to a layer of 1-inch blue rigid insulation, R5, and then we hit the pine sheathing, which sits mounted on the original size 2x4s that are the structure of the house. That's what we started with. We ripped everything else off on the inside. Then we proceeded to add, first of all, the isonine to the cavity and all the exterior walls. We filled it. And secondly, we added the vapor barrier, shown here in the red, just on the inner surface of those 2x4s. Once that was in, we installed the horizontal 2x2 strapping all through the exterior walls of the house. And then at that point, we added all the utilities that we needed to add within that cavity. You'll see pictures of this coming shortly. Once those were set and done, and everything was ready to go, then we added the insulation, the Roxel ABF. ABF, it's just a name. it's an acoustic bat insulation that's used in commercial projects because you can get it in half-inch sizes. I don't need 3.5 inches, 5.5, 7.5. I want 1.5. It's on the shelf. There it is. Give me a truckload of that stuff, and in it goes, right there. Fits perfectly. And we actually spaced, of course, the horizontal to the exact dimension of the bat. No need to cut anything. So after that, we put the drywall on. Mounted the drywall, painted it up, cleaned the house, put the carpet down, lights in, finished it up. But that's the wall assembly we're dealing with right now. And we're going to see how that's been installed through the next couple of slides. Here we have the bare 2x4 structure and the exterior wood sheathing behind it. That's the rear of the house with the old doors and old windows. New floor going in. We like the look of a new floor, nice and level. The old house had a bit of settlement to it, so we dealt with that quickly. Here goes the isonine spray foam. It's an open-celled foam. It's fairly light. We decided to use it in this case. This is February 2006 we're talking about here. That's 9 years ago. Whoa. You could have a 9-year-old child by this point. That's a long time ago. So in 2006, we had them come in and do all the exterior walls, as you can see. Went in quick, and then they trimmed it off, flush to the inner surface of the 2x4. Here's a view again to the back of the house. After we had the isonine foam trimmed, we then proceeded with the vapor barrier on top of the foam, sealed at all the joints, of course, floor to ceiling. We had the junction at the ceiling. We actually used a spray-on vapor barrier at the ceiling at the floor joist junction there on all the floors to sort of bridge the vapor barrier gap between the floors. But the vapor barrier itself is sealed here at the bottom and at the top with the sealants that we use for vapor barriers, and of course red tape here and wherever else we needed it around the windows. At this point we have the framing for the new windows in. The new windows are still on delivery at this point. So you can see the setup though. There's the horizontal strapping, and that's there's one of the bats there, another one there. At this point it's starting to feel very comfortable in that house. Before it was empty and cold. Now, oh, this is really nice. This is showing the next step. Now we're calling in all the trades. So over the next 6 to 8 weeks, the plumber, electricians, HVAC, data, doors and windows were all installed in that framework that we've got set up now. As you can see, there's the heating, there's the Cat 5, there's all the electrical, there's the outlet boxes. They're all inside the vapor barrier. If there's a penetration, then we seal it up with foam and red tape as necessary. There are very few penetrations in that vapor barrier. We need electric supply, cable TV, telephone, and one outside outlet and another hose bib outside. I think that's pretty much it. A couple of exterior lights, but very minimal. We could, you put them on 1 or 2 hands. So once all those components are in, then we can put the bat insulation in, get our blocking in for all the things we're going to hang on the wall, and then call a drywaller. Have them come in, do it, tape it up, paint it, put the carpet in, clean things up. Now that took, of course, a number of months. And I'm not even going to go into the mechanical. These are just the delivery lines, of course. It's all rad heated in this case. There are no floors that are heated. It's all rad heated. and it's very comfortable. There's the final result. That's our office right now, the front room. That's you were looking at that same wall there. It looks like a regular old wall. Now, I'm just going to show you a few bits of data that I recorded. So what this is showing is the heat requirements of the house before we bought it. That says 113 million BTU. Now, there's kilowatt hour. There's a lot of conversions for that, so somebody else can do that math if they'd like. But that's the BTUs I recorded from the gas consumption of the house prior to our taking ownership of it. And then I recorded the consumption of the BTUs after the renovation was finished when we were actually operating. It's 19 million at that point. We have a reduction of 83% on that wall system and those doors and windows, basically. So we're pretty happy with the result, and it's very comfortable inside. There are no drafts near any doors or windows or walls or cracks or anything at this point, because there are no doors that are that leaky or cracked. In 2006, we couldn't afford to upgrade the exterior cladding the way we had hoped. At a future date, we can continue with phase 2 or phase 3 or wherever. There's a lot of phases in this project. So on the exterior, as part of that advanced wall system, we can remove the exterior cladding and get ourselves a permeable air barrier, like not the Tyvek, but one of the more advanced systems that are out there. We could add something to reduce any kind of air load on the outside. Then we can upgrade the cladding to increase the insulation value, and then put a finished cladding on that suits us. But that's, of course, based on money and those sort of things. So there's still possibilities that we can improve it beyond 27. I just wanted to comment on what this is connected with. This slide describes the additional systems and features of our office renovation, in addition to the advanced wall. We have an extensive green roof on 1/3 of the roof area. All the windows are triple glazed R7.5. The roof is R50. We use off-peak electric or biomass heating only in this house. We use a heat pump for air conditioning. It's a little extreme, but it works well. It's a small heat pump system. It's not a deep well system. It's a ground loop system, so that's why it's just used for air conditioning. We have an HRV supply system. Works beautifully. In the warmer months, spring, summer, fall, we don't use the HRV because we have a passive airflow through the house. We have skylights, we have hopper windows, we have screens, we have lots of stuff. Just open something and up goes the air. It's beautiful. And it's free. Did I mention that? We have a power pipe, of course, because we like to retain that heat. We have rough-ins for future solar hot water and solar PV panels. Those, of course, cost money. We only wanted to get this project in place and running. They are piped in case we'd like to add them in the future. We also have a nice feature here, flexible occupancy configuration. This house can be reconfigured at any time, depending on who the occupants are. Right now, we're the occupants. We have 2 semi-detached houses combined as one, with an office in the downstairs of the new side. We can reconfigure that very quickly, very simply. It can be, one half can be sold. We can have an apartment on the top of one of the houses. There's a lot of possibilities to this house that are quite nice. When you think of downsizing, you just close off a door and then you rent that part of the house out, that kind of thing. There's a lot of flexibility here. So, together with the walls, these improvements have resulted in a remarkable home and office demonstration of sustainable design that we show our clients as often as they like to see it. Thank you for coming to our presentation today. If you have any questions, we can answer them after the presentation.